Hi everyone, I am Timothy from Cognito Academy, and in this video, we will be covering scalar and vector quantities in the topic of measurements. Let's first see the difference between scalar and vector quantities. Both are physical quantities, just that scalar quantities only have a magnitude, while vector quantities have both magnitude and direction. Let's look at an example of a scalar quantity. Mass is one such scalar quantity, where it has a magnitude of 3 kilograms, but there's no direction associated with mass. On the other hand, a vector quantity like force has both magnitude of 3 newtons and a direction towards the right. Let's look at more examples of scalar quantities. We have distance and its derivatives area and volume, time and its derivatives speed, mass, density, and also pressure. Although pressure is a derivative of force, which is a vector, pressure is scalar because it has magnitude but no direction sense associated with it, as pressure acts in all directions at a point in a fluid. All energies are scalars, including gravitational potential and kinetic energy, along with its derivatives work done and power. Temperature, current, and its derivatives potential difference and resistance are all scalar quantities. From all this, an observation that we can make is that all base quantities are scalars. Let's now dive into vector quantities. We know both distance and speed are scalar quantities, but if you think hard, you'll realize that there can be direction associated to both of them. Hence, there are vector quantity equivalents for both of them, namely displacement and velocity. Let's look at an example of this bus here. The scalar quantity speed is only concerned with the magnitude of 30 km per hour on the speedometer, whereas velocity is concerned not just with the 30 km per hour magnitude, but also its associated direction towards the left. Let's look at other vector quantities such as derivative of velocity, which is acceleration. Forces such as weight and drag force are vectors, along with its derivative moment, and also magnetic field. Next, since vectors come with a direction, there must be a way to label and describe the direction, which introduces us to the concept of direction convention, which is just a way of setting which direction is positive and which is negative, which in this case we set the right to be positive and left to be negative. In a scenario of the bus moving at 30 km per hour towards the left, since the left direction is negative, mathematically speaking, in this case, the bus is travelling at negative 30 km per hour. This will make calculations simpler, as we can see in the next example. Here, we have a box with two forces acting on it. With the direction conventions, we can say that positive 5 Newton of force and negative 2 newtons of force are acting on the box. Adding both forces together gives us a resultant force of positive 3 newtons. And since positive denotes the right, the resultant force is basically 3 newtons towards the right, or 3 newtons 90 degrees clockwise relative to the normal. Another thing to note is that the length of the vector arrow is proportional to the magnitude. Therefore, 5 newtons has a longer vector than 2 newtons. This wraps up our video on scalar and vector quantities. If you found this video helpful, please like, subscribe, and turn on the notification bell to stay tuned to our content. Also, check out our website at www.cognito.academy and follow our Instagram for more awesome academic content. See you!